Hi guys, question number 1 here from more Stiochiometry questions. If you can see 4 moles of methane react with 10 moles of oxygen, and the equation give you 1 mole of methane is 2 mole of oxygen, so it means 1 to 2 ratio, but they give you 4 moles methane is 10 moles of oxygen. It means I think oxygen is more than enough here. So we know that our methane will be our limiting reagent, and that's all for that question. Question number 2, 2A plus 3B gives you 1 mole of C. So you can see clearly here that 2 moles or 3 moles of B according to equation, but 2 moles of A are mixed with 4 moles of B. So it means again we can see clearly that again B is more than enough. That means this is limiting reagent, and then we link with this with our C, which we need to find. It is 1 mole of C, and that means that is 1 mole is the answer for this question. Question number 3 here, the formation of ammonia. Masses are given to you. You need to make sure find the moles to find the mass produced by ammonia. Now 14, if I find number of moles of here nitrogen, which is equal to mass over mr, 14 divided by 28, because nitrogen is 14 times 28 is the molar mass roughly, which is equal to 0.5 if you calculate from a calculator, and moles of nitrogen, and then I calculate the mass of hydrogen. So number of moles of hydrogen, so number of moles of hydrogen is equal to mass going to use 6 and divide by 6, because 3 times 2 is equal to 6, so that will be equal to 1 mole of hydrogen. And that means that if I want to find the now we understand clearly this is basically axis reactant, and 0.5 nitrogen is a limiting reactor, so I will use this nitrogen here and to find the mass of ammonia. So very clearly, so 1 to 2 ratio here, and we already got moles of nitrogen is equal to 0.5 to x, and that means I'm getting 1. So 1 mole of ammonia should be in mass multiplied by 17, because 17 is a mr of ammonia roughly, and again you get roughly 17 gram is the answer, and I think that is matching with your A answer here. You quickly do this number 4 here, and you see we are talking about lead nitrate, and this thing I'm concerned with this one. I change the color, and reacting with potassium iodide. So these two things, when they react together, and I already made the equation which is in red, so lead nitrate reacting with potassium iodide makes potassium nitrate and lead iodide. So you need to know this thing, all nitrates are soluble when you have ton of course ionic bonding. So you know this thing, in ionic compounds all nitrates are soluble. So this is also soluble aqueous. Potassium iodide is also soluble. Most of the halogens, chlorine, chloride, bromide, iodide are soluble. However, this lead iodide is insoluble, so I should write it as solid. So that means solid means is a precipitate forms here, and that means we are having the precipitate for lead iodide, and my answer should be lead iodide here. Going to question number 5 now. See which of the following spectator ion. Spectator ion is that ion basically which is a repeated ion in any chemical equation. Now what happened here, that we are having silver nitrate and sodium chloride. Silver nitrate and sodium chloride means I think we are having aqueous, because as I mentioned to you, all nitrates are soluble, so this is also soluble straight away. And I know this in sodium chloride can be dissolved. Salt of course can be dissolved in water, and I can write straight away this one is AQ, and the only thing is left, silver chloride is insoluble salt. I should be writing here. So it means that I think this is my equation. Now I already made an equation, complete ion equation for this one, which is I broke down silver nitrate into silver plus and nitrate minus, same sodium plus to chloride, and silver chloride cannot be broken because it is solid, and sodium and nitrate can be broken. We can see that I think those things are repeated here. It's of course either sodium and nitrate, and these are your spectator ions, but because nitrate is not given, so sodium is your answer in that case.